start recording of this session on different tool sets. Okay, so the just a reminder, since now basically there was a problem with this Google Plus chat. Since it's actually the Google Plus chat or this kind of the community is only for companies. It actually also means that I cannot give access to anyone else than Metropolia, the users, or actually those who has Metropolia Google account. So for that reason, for our official chat channel is Microsoft Teams, and let me show you the Teams window just quickly here. So there is that I sent you invitation to PSoC Design TX00DB 04 2020, this Teams workspace, which has some topics here, general kind of stuff, fundamentals, timers. Oh, okay, yeah. Then these 5 exercises, and then at the last there's the project. So my idea was actually that when you have a question, you would post it here. You should be able to post it. I have given all the guests also the right to post things on these chat rooms. So basically there's an example of conversation that was actually direct conversation from direct chat from Teams. Okay, that's also fine, but nobody else then will see the this question, and nobody else can see the answer. So basically I copied a direct chat to me and copied this question and also the answer. And actually this kind of questions and answers would help the others also. So as I said last time, most of you probably have a question that somebody else also have, and actually this is, say, I had very similar question also from another student on the same course. So and I gave exactly the same answer. So to basically remember, the sharing is caring. So if you have a question, share it with each others, and also then you can start giving the answers to each others. So what I'm trying to do here is to make myself obsolete. That's my plan, evil plan. Okay, and it's just not. It's not just to the downsize my own workload, but also you can get the help faster when there are something like 32 other students on this chat. So there are more answerers for the same questions. You get the answer faster. Okay, so but anyways, the fundamentals you can still put some posts there. Same thing. If you have a question for the second exercise that was not covered on this session, you actually could post it on these timers and interrupts on the posts. Okay, good. That was a start. Let me close that one. And now basically on the fundamentals. Fundamentals. Oh yeah, I have a slow connection here. All right, so most of you probably have went through the video tutorials. Those are quite short. exercise, this exercise 1 tutorial right here, the introduction is short, but then PSoC creator and IO, this is a little bit long, but anyways, it's worthwhile to go through that one before starting the exercise itself. And then of course, before returning the exercise, it would be a good idea to go through the demonstration of the expected results. So there I'm actually showing you what I'm expecting. So I have done these exercises myself. Yeah, that's rare, I know. That the teacher is actually also doing the exercise. But anyways, I have done the exercise myself, and this video actually shows what was my result. And okay, it does not need to be exactly the same. You can also, there were a couple of excellent exercise returns. They were actually also giving something extra. The functionality was there, but also something extra, like not just bare number printing out, but also a kind of the string there saying what number that is. That was a good addition. Okay, good. Otherwise, at least the returns were pretty well done. I checked those, let's see, this morning around 8 o'clock. So if you have uploaded new returns after that, then basically I may not have seen those yet. But as I said, tomorrow morning I'll start going through the exercise 1 returns. Then I also noticed on my return form that I didn't actually click there that to have the email confirmation of that the recording was done. I have now added that one. I did it about half an hour ago or something like that. So now on, when you return an exercise, then you also should get a the notice that the exercise return was actually recorded. That was missing from the from my form. Sorry about that. Okay, so then let's go to the questions and answers. And yeah, there is somebody saying I have some problems with the last tags from exercise. Let me put that one to chat also here. You should be also seeing that one. I have some problems with the last task from exercise 1. Okay, what kind of problems? And Maximilian, you can also use the microphone now, so just unmute yourself and describe your problem and see if we can actually find a solution.
So, good morning.
Good morning. Yes, we hear you well.
Okay, perfect. I have some problems with the order, so I don't know. I used this tool you showed to show us how which data comes from the port, and I see nothing there. This doing putty, and there's no result I can see when I use this the code.
Okay, so you cannot see anything on where?
On the putty. So I start. I use this code URT start. Then put some string on it.
Yeah.
With my name, and the result had to be that I see this on putty.
Yes. You have the correct ports. Otherwise, it wouldn't open.
No.
Okay. If you can't see anything.
I look into a manager. It's COM port 3. So use putty with COM port 3, and there's nothing.
Okay. One possible reason is that did you allocate the correct pins for the for the what?
It's 12.6 and 12.7.
Yes, those are correct.
And is it right that I used the code URT start under
Yeah.
the global enable for interrupts?
Mm-hmm.
So it's the first thing I need to do to start. Is it right?
Yes. Let me give you some permissions here. Where did I lose my Zoom windows? Oh, there. And the participants. I will make you a co-host. Then you can share these your screen, if that is okay.
I looking on an iPad, not on my computer.
Oh, you on the iPad? Okay, that's then it doesn't help much. It's hard to tell without seeing. Did you return the exercise already, or do you have somewhere that I can download it to my computer?
I can upload it, and maybe we can chat later, so you can make
Yeah.
your.
Yeah, that's a good idea, since otherwise it's hard to tell, since it can be. Have you actually also asked somebody of your classmates to check on their computer, since there have been at least one broken device already, and that I think that problem was solved, I hope. Oh, there's okay. Rene is asking baud rate. Did you click the correct baud rate?
Yes.
Okay, good.
I've checked all those parameters. So I send you the code later, and then we can talk.
Yep, yeah, let's do that. Yes, and please use, for example, you can return it by this exercise return system. Then it's basically a link to link to the exercise.
Okay, perfect. Thank you.
Okay. Thanks, Maximilian. Anyone else? Any problems on the first exercise? Okay, it seems that nobody else has problems with now to share. So we can move into the second exercise, which was about timers and interrupts. Okay, yeah, the interrupts is the probably the most important topic on embedded systems programming overall, since, well, that's how you make things to work. So practically all these kind of embedded systems, they are based on having interrupts. Something happens on the hardware or software, and basically then you need to have some specific software that runs after something happens. For example, just pressing a button will start some system and so on. Or in my small project, this let's see, do I have it somewhere? Oh, yeah, there. Let me show you an example of my project that I last time showed. I'm working on a electronic fishing lure. Okay, and the prototype, I hope you can see that one, or actually would let me stop stop the video. Let me actually open a camera. Camera window. Yep, there we go. That's my camera window. That's a prototype for the fishing lure. The final version would have the plastic covering and stuff like that. And there the idea is actually internet connection is unstable. Let me make this one a little smaller. So the idea is actually that there's a capacitive sensor. This capacitive sensor here is just a twisted pair of wires. There's some picofarads, 10 picofarads about this length. Oh, actually that looks more like maybe, let's see, less than 10, something between 5 and 10 picofarads. 1 centimeter of twisted pair is about 1 picofarad on that wire. But then you can change the capacitance of this wire by changing the permeability of the media, meaning that if this is on water like that, then basically this should, well, let me do I have the correct program here? Sorry, I don't have the correct program here. But anyways, basically by putting this one on water, basically this processor noticed, okay, now I should start doing something, and well, you just must believe that in this case it would just blink the LED here. But anyways, the idea of having interrupt based system is that you would something changes externally and then your system starts working. Okay. And the interrupt basically is the way to go. So to make those interrupts work, you must have an interrupt the service routine, and also you must have the source for interrupt. Then you must hook this source of interrupt to the interrupt service routine, and then you must, of course, you have to code the interrupt service and how you do how do you. So those are the fundamental parts, and then on the code you must enable interrupts. Remember to also, whenever you have interrupt service routine, you need to also enable the global interrupts. That's the one macro statement on the beginning of the code usually. And then you must start those interrupts, which means that you need to call those the component start routine. And in the case of interrupt service routine, you would probably want to write your own routine and introduce it on the main.c. Okay, more details are actually on the on those data sheets. Okay, but now there are a couple of good questions already there. First is from Alexander. Should the motor go to his start position smoothly as well? On the beginning, it's quite impossible to know where the position of this motor is. So basically, on the start position, it can go. On the middle position, when you start the program, it can jump as fast as it can. Okay, but after the first one, then it basically should go to those at least 5 different points smoothly as possible, not smoother than that. Hey, who said that one? make everything as simple as possible, but not simpler than that. I think it was Albert Einstein. Interesting. Okay, so yeah, so the initial state at the middle for this motor, it can jump there. Then what kind of function does the PSoC offer for capacitive sensors? Ha! All right, I will show you. If somebody wants to make a project from capacitive sensing, I have a challenge to give. Capacitive sensing, let me see if I can open it from here. Open project. What project is it? Just a moment. No workspace open. Huh. Computer is a bit sluggish today. Is this the one that works? Sleep all. Unstable again. Wow. Okay, maybe it works. I'll just check that this one works. Yep, this one works. So that was the code I wanted to show you. Let me open the camera again. Okay, so now this device is on sleep mode, and whenever there's some water present, well, my fingers are actually emulating the water, so there's a LED start blinking. The next step on the hardware basically is that I will, instead of that LED, or in addition to the LED, I'll put there a transistor and then run one of these vibrator motors. So that's the luring part of for this. So practically whenever this is on water, then it starts doing stuff. Okay, the capacitive sensing part. Top design. There is a component called CapSense CSD, and let's open the datasheet. There we go. There's everything what you need to know about the capacitive sensing in this PSoCs is right there. It takes a little while to get this one working, but actually there are also some example projects on Cyber's website which helps you getting started. But there is a challenge. Power consumption is a challenge. This microprocessor core takes less than 2 microamps if it's if you basically put it on sleep mode. But then they also claim that you can actually have a capacity sensing also on sleep mode with 1 second reporting rate, then it should take typically 8.2 microamps. I haven't got that yet. I have got, say, less than this, but say much more than that. And in my application, this is way too high power consumption on sleep mode. I need to get it down to this one. So in that case, I would have 10 microamps sleep mode current, which means about 3 months of battery lifetime without recharging. If you have an electric lure, you are not putting those on charger all the time. Okay, now we have another question about some topic. All right. Okay. Voltage reference seems like isn't working when I use Vout as Vref. The output of the ADC fluctuates and gives me nonsense values. VDD looks better. Okay. Yes, the capacitor. Try to add that capacitor. There's supposed to be a capacitor on your kit, at the 100 nanofarad capacitor. Yes, otherwise it will fluctuate. That was good. Thanks, Rene. And that's oh, you're already on. You're already on exercise 4. That is excellent. Excellent. Okay, more questions? Yeah. The bypass capacitor for that chip. Let me go. That was SPI exercise. I will show you in here. PSoC exercise 4. Voltage reference. Let me get the data sheet for the voltage reference. Okay, so typical application circuit. It has 2 capacitors. The input capacitor is optional. I didn't use that one, but actually, well, the output you need to have well, here it's 1 microfarad to 10 microfarads, but you need to have a capacitor there. So 0.1 microfarads actually also works for better than 1 degree the accuracy. Okay, excellent. More good questions. Okay. Add code to timer1.isr or something like that. Where do I put my code that is not deleted? I will show you. For example, on this project what I'm working. Some interrupt service routine. I have one interrupt service routine. Everything here will be regenerated, written over, unless. Okay. Okay. If you have includes defines code like that, you actually would put it between these start and end. So if you put some code there, that will remain. So practically what I did here, I had this timer. I'm calling some timer routines here, and I then have a external variable, global variable here. If they are declared in this between the start and end, those will be that code will be remaining. And basically same thing here on the interrupt service routine. If you put some code, oops, sorry about that. If you put your own code, there's always a path for that one. You can edit these files, but everything else, if you put your code here, for example, if you put any code here, for example, comments, code, and do generate application. Let's see what happens. No, it didn't actually remove that one. Yes, because it was just code, it didn't need to do anything for that one. But anyways, regenerating this application basically should take out everything else except what is in between start and end on the files that the PSoC creator makes. Debounce. Yes, I can show you. So you know one that a fundamental problem with electromechanical switches is that you actually usually, especially on releasing part or actually pressing part, when you press the button, it's not a instant press, but the contact may actually have some dirt on it, and then it basically practically bounces this switch. So that's the switch is on and off within, say, 1 microsecond time or something like that, very short time. It's on and off. Okay, that's the switch bouncing, and it's if the bouncing happens, say, in microsecond range, it can actually generate more than one interrupt, or it can be actually on the software. You have time to read it really fast. So basically, you can get multiple pressing multiple presses. These PSoC boards, what we have, these switches are pretty good, so they make the contact immediately and just one contact when you press it or release it. But cheap contacts, or if you just take wires, if you just have 2 open wires, then you definitely get more than one on the switching the operation when you try to do just once. Okay, so there is a debouncer the component. So read that, what it does, and actually there's also the application notes which describes the bouncing better. And is it necessary to use it? Yes, in case you have a cheap switch, then you need to do something for the debouncing. But for these boards, I have found that these switches are pretty good ones. And then next, should the signal pulse period for the servo motor always be 20 milliseconds? Not always, since servos, there are plenty of different. These so-called standard servos, what we are using, these small devices, they which are used on toys and small things like that. Then basically they use the 20 millisecond pulse period, and the middle position should be 1.5 milliseconds, and then plus minus something will give you the whole range, and that's device dependent. So what you practically need to do with these servos in real life, you need to find the specifications for that each particular servo separately. More the power you need, then they usually have different kind of the interface, and not speaking of the digital servos, which may have SPI or I2C interface. So, but for these small devices which have just three wires, and usually they don't have any data sheets available other than you need to Google them around similar servos, then you can actually start it with the 20 millisecond and default pulse period. Okay, more questions? JSON output. You can actually use pre-written code for JSON output. Yes, definitely you can do it. It's also good exercise for the exercise, basically how to include a pre-written library to a project. It's a good idea. One good source would be to check the arm.org and see what they are there. Just be sure that there's a you are following the copyright. Just a reminder, when you are borrowing a code, you may need to fix that library code, the initial routines, or these what are these called? The basic routines to interface it correctly with the existing the hardware and software what you have. Yes, external libraries is allowed in general. Yes, it is, and yes, it's also okay to write it yourself. Both, as long as it works, then it's fine. If you're using somebody else's the library, make sure that you have the permission to use it. They usually are. If you Google something and find it from internet, then if you're not going into those Tor networks but from public internet, they usually are on or for the what is that? Creative Commons licensed or something like that. And actually, you can also team up so that somebody will be making a library. And remember, sharing is caring. Making a library, and for example, in here, that was on the data acquisition, I think. There's also a place for files. If you write a nice software for the for example, JSON that fits nicely into the this PSoC environment, well, you can share it with your friends here. I can actually take those into account so that if you share a working library with others, I can then give you some extra points in case you need any extra points, that is. Let's just answer that one there. Okay, more questions? Yeah, exercise 4. Yes. Answer is yes. SPI sensor data also need to be filtered by moving average. More questions, comments, anything? Oh, yeah, what battery do you use for your fishing project? Let me see if I have a model here. I'm planning to use Turnigy. Let's see if I can find it from somewhere. Let me go first, open it on a different window. I'm planning to use this one single cell 3.7 200 milliamps hours lithium polymer. So that's the that should be enough for this basically to drive this vibrator, since I have measured the vibrator motor and it takes a couple of amps when it starts, and then it takes about 200 milliamps 200 milliamps when it's running. So basically having this kind of 200 milliamp, it has to be at least 10C, but this is quite cheap device. I can get 6 of them at total price of let's see, 12 plus 5, so about 16 euros for 6. So it's less than 3 euros a piece. So cheap batteries, standard technology, nothing fancy. So that's my plan. Okay. Back to my voltage references. My values are somehow still 2 degrees off. Are they fluctuating 2 degrees, or is it 2 degrees different from the PSoC2020 value? Stable. Okay. If it's stable value, then I would say your PSoC2020 converter is not giving you correct values. Have you checked what is the A to D converter resolution on your chip, on PSoC chip? Yeah, ADC delta sigma. Yes, that 8-bit. Ha. Okay. Think about it. What is your absolute resolution on your A2D now? 1 bit equals to how many millivolts? I think your problem is there. You're using a quite coarse setting on your ADC's delta sigma. Okay. So answer first. Yeah, let me first answer that one to the that's a chat and ADC delta sigma resolution. And then which 5 positions you have to bring. Okay, you can pick the positions yourself, but I would use say 1 millisecond, 1.25 milliseconds, 1.5 milliseconds, 1.75 milliseconds, and 2 millisecond the positions. For example. And then back to beginning, which is the 1 millisecond position. Okay, let's see, but I'm not using the delta sigma for the values coming. The SPI, the SPI A to D converter, that is accurate. The problem is now the delta sigma. You don't have enough of resolution on the delta sigma. If it's 8-bit full range is 4 volts. It means that your resolution is around 16 millivolts with these 1.6 degrees. So you are reading SPI correctly, but your sigma delta gives, or delta sigma, ADC delta sigma inside of the PSoC, that gives you wrong values. Not wrong, but not accurate enough. You need to increase the resolution of the delta sigma. On the settings. The component settings. Okay. More questions, comments? If we use a global interrupt, can we write in this main like your demo video? Global interrupt. Okay, the global interrupts actually need to be need to be enabled, and basically that read the documentation on the how these PSoC interrupts actually are working. So the interrupt engine inside of the PSoC actually, or inside of the ARM processor, actually the interrupt controller is enabled by setting the global interrupt. But how these individual interrupts then work, there are up to 32 interrupts available on the on this core, and actually then let's see how does it go. So practically what you need to do, let me see if I can actually, let me close that one. Okay, or you have to program this in the corresponding interrupt.c file. I see. Okay, this is basically the question. Now I sort of understand what I'm asking. So you can actually add. Let me open a new project from scratch. For example, there. Okay, that's just fine. All right, let me put an interrupt here. For example, a button input, digital input pin, and then I will just make it a digital input with resistive pull up. Apply that one. Okay, and then just have, oh sorry, I need the hardware connection just to interrupt service routine. Interrupt. Just a simple routine that gives interrupt from pin there. Now it's connected pins. Pin number 2.1, 2.2. Well, it is 2.1, so this is 2.2. There we go. Generate application. So there are two places where you can actually put this interrupt service code. Okay, generating. This takes for a while, I see. Detail placement. Oh, actually, there are three different places. There are different options how you implement the interrupt service code itself. So option number one. Option number one is go into the ISR1.c, the interrupting code, and put your globals between the start and end here. If you need any globals, then somewhere in here you have the code. So this is one place to put the code inside of that interrupt service routine which was generated, which is serving this button press. Okay, That's one place, but actually you can see it from here. You can also define your own code, which will be then the actually opened. So you can have that one defined anywhere as a code, for example on main.c. So after that one you had the whatever the button ISR or my button ISR code, which you need to run as the interrupt service code, and then you would have the your interrupt service routine itself defined in at the end of the main in here. Okay, close those. So those macros are actually defining. This one gives the prototype, which will be used in here. And this will be the code. On this course, I prefer this method because then I can give you comments. I can give you some comments on the on your exercise return. But if you have a bigger code yourself, you can of course go and create a. Okay, let's see how do I go and add a new the new file, C file, for example, named, rename that one, how to rename it? Which has the that code, cy ISR. Somewhere in there. And that, where did it actually go here? Wait a minute, why didn't actually go as one of those? Ah, sorry, I made it wrong way. So on source files you would add a new item C file here, which has this code. Instead of there you would have the code in here, and then of course you need to have includes here or two, remember. Project.h, okay, and then save, and then you have header files, add a header file for that one, new item header file, blank header, and that would have basically the required stuff. For example, you would have the that one defined in the header. And of course include the project.h, and actually then you need to include your own header 01.h here. Okay, that's the kind of professional way. You encapsulate your own interrupt service codes in one file, having the header file, corresponding header file, and then include the header file on the main, and basically, or actually you could include it inside of the project on the space which is reserved for your own includes, and then you would just basically call those functions here. So in this case I would call ISR1 a start external and your own code there. So that's the way to you can do it kind of professionally. But as I said, I prefer the way that you would have these the prototype inside of main.c, and then also the interrupt service code on the main.c. Okay. Any other questions? Okay, if not, I will stop the recording.